Let's divide this solid sphere into spherical shells. So at x distance from the center, we consider dx thickness. That's a spherical shell. Let us consider an outside point, external point. So due to this fellow, potential would be this much. It would not depend on x. For a shell, it's like a point placed here. For various shells, potential would be obtained by adding or integrating and for everybody these things are constant. An integral of dm would be m. So the results look similar to the result of spherical shell. It's just like saying that keep a point mass having the same mass capital M. For external point. For external point, if you want to find the potential, replace the solid uniform sphere by a single particle having the same mass. The radius not important. Interestingly, radius is not coming anywhere. So whether big or small doesn't matter. Mass matters. Any questions about external case, let me know, or we go to internal case. Internal case will be more difficult. Alright, internal case. Suppose now we have point somewhere here. Distance r. Now we divide the sphere into two parts. One part inside this radius, small r, and one part outside this radius. Let me rub off this part. Let me try to show that border line by some dashed line. Now, potential will be contributed by masses which are outside this imaginary boundary and inside the imaginary boundary both. The mass which is inside things are very easy to handle because that mass will act as a particle. How much mass is inside? Mass per unit volume is this. It's a uniform case. So mass which is inside that dashed thing is this. So the inside mass is this, and it will act as just like a point mass. So V due to that mass, interior mass, is minus G, the mass itself, divided by this distance from the center. That means minus Gm R square by A cube. Then how about the outside fellows? Now I don't need this inside. Let me see if I can extend it. Outside fellows. So we can visualize several concentric spherical shells outside. If the mass of this fellow is dm, which is at distance x, where x is necessarily more than r, or limiting case equal to r, then potential at small r due to this dm would be how much? Little dv ext, that would be minus g dm by x. I hope you remember the result. For inside points, what happens?